Good afternoon. Welcome to one and all who are joining us through this webinar for PRL Colloquium. Today, we have a speaker from IIT Gandhinagar, Professor Vikrant Jain. I take this opportunity to welcome Professor Jain and also colleagues of IIT Gandhinagar who are joining us live in this mode. To introduce our speaker formally and also to conduct the proceedings, I'll invite my colleague, Dr. Sanjeev Kumar, to please do the honors. Sanjeev.
Thank you, Professor Pallam Raju. So friends, it is a pleasure for me to formally introduce Professor Vikrant Jain. Professor Jain is a fluvial geomorphologist with basic training in geosciences. He is a faculty member in Earth Sciences discipline at IIT Gandhinagar, where he also heads the Natural Sciences division. Professor Jain did his MTech in Applied Geology from IIT Roorkee and PhD from IIT Kanpur in 2001. Subsequently, he did his postdoctoral stints in Australia and United States. In 2007, he came back to India and joined as a faculty member in the Department of Geology, Delhi University. And Vikrant came closer to us actually, that is at IIT Gandhinagar in 2013. Vikrant's research interests lie in the field of river science, earth surface dynamics, geomorphic applications in stream management, and rivers' future in response to climate change and anthropogenic disturbances. Vikrant has developed a process-based understanding of different spatiotemporal aspects of Ganges plain rivers, peninsular rivers, and coastal rivers in Australia. He has mapped the driving force, that is stream power, in different fluvial systems and evaluated its role in river processes. Professor Jain has published around 50 peer-reviewed papers and is recipient of National Geoscience Award in 2018. Currently, his research focuses on understanding the complex behavior of river systems in response to external forces at different timescales. His research work also aims to integrate geomorphic tools with hydrological, hydraulic, and ecological datasets to develop a framework for sustainable stream management. So with these words, I invite Professor Jain to deliver the colloquium.
Many thanks for this invitation, and it's an honor to discuss my research work to the audience. I'm going to first share my slides and then I will start. Okay. So once again, good afternoon. So I'm going to discuss about the rivers in Anthropocene and mainly is assessment on the Indian rivers. So first, Anthropocene, this is a new word, and to introduce this word before, I would like to give a brief overview about the geological time scale of Earth. Earth is a 5.44 billion year history, and then whole time zone has been divided into different periods on the basis of major events. These were the natural events, and then governed by tectonics, climate, sea level change, major impacts. We have seen, so the Earth has seen the different kinds of processes and the evolutions of landscapes as well as the biological species. Recently, this last 2.58 million year known as the Quaternary time period has become very important because of the climate change issues. Now, there are further different layers within the Quaternary on the basis of climate change scenarios. And the recent one is the Holocene, which is marked here. Maybe I will change the pointer option. The recent one is the Holocene, and which start from 11,000 years to this present time period. And also there are some more episodes of climate change which have been recorded, and they have been marked because there's the impact of those changes were significant on the Earth's surface. In 2002, Paul Kaltner, who was also a Nobel laureate in the chemistry, mainly in the atmospheric chemistry, he has written a paper on this and then introduced the term Anthropocene. What he mentioned is that part that now the impact of human is significant, that we can think about it a term as Anthropocene, because the impact is because this human impact is going to affect the whole landscape. That paper was mostly focused on the climate change impact and then some of the deforestation ecological aspect. After that, number of papers come, and some of the papers have come out with more earth surface processes. Like in this case, in 2008 paper, Jasvik has mentioned that the degradation rate, the anthropogenic denudation rate has also increased significantly. It means that the sediment supply has increased in the system, and then the processes on the earth surface has increased. So there were different papers, they were looking for the geological process, and things have changed from atmospheric to geological aspects and the thing. Another important work was this Montgomery work, where he suggested that the rate of soil erosion is more than the rate of the development of soil, which is governed by the weathering processes. And this is wherever the agriculture activity is going on, soil erosion is significantly higher. And that gives us sustainability issues, because it may be possible that in near future, most of the soil will be gone away, and it will create a challenge to the food security. And recently, I read one more paper. There are a number of papers are there, but this paper is only to highlight that the Anthropocene has now become much more interdisciplinary topic. This paper is in the Royal Society of the Mathematical Physics and Engineering Sciences, where we talk about its implication and why there is a need to define the Anthropocene. And now the numbers of papers are coming in the humanities and social sciences as well. So Anthropocene is more about impact on the earth surface. I will take a small component of the earth, which is the river, and then number of papers have also come out on the river in Anthropocene, especially in the last decade, which is there. In 2005, there was two interesting paper. Both of the paper was on the impact on dams on the river. One was talking about the flux, sediment flux distribution, and second was talking about the fragmentation of flow, about the water disturbances are there. Another one which further highlighted that even the deltas are sinking. The human impact is not limited within the river system, but deltas are sinking, and this reason was that because of the exploration of oil, the compaction of soil has occurred, so this subsidence is going on at many of the deltaic region, and further the sediment supply has reduced because of the dam, and so the rate of aggradation is less than the rate of the sea level rise, and hence this high rate of delta subsidence has been recorded, and few of the deltas of the Indian Peninsula or even the Indo-Gangetic Basin was also in those lists. Again, more and more paper were there on the dam, and then and its impact on the sediment busting, yellow rivers, Amazon basins. And one recent paper is about the change in seasonality. It is not only the sediment or dam has occurred, but the atmospheric processes are also taking place. It means that the seasonality has changed, the occurrence of flooding has changed in those scenarios. This is all about the European rivers, and these papers are there. But the work which has inspired me for this presentation is the recent paper on the anthropogenic stresses on the world's big river. Jim Best has discussed number of rivers on the world, and he mentioned that most of the rivers are under stress because of the anthropogenic impacts. Human impacts are there. The name of Indian rivers was also there. That was mostly with reference to the main problem of the pollution. But besides this, he also discussed many aspects. Of course, the sediment busting, fragmentation, ecology, geomorphological issues are there. So in this talk, I'm going to discuss about the Indian rivers, and an aim is to discuss what is the present condition of our river systems and what's the future of rivers on the basis of this particular emphasis. And this question is important because we have seen in past, now there is a good amount of literature is there, that there was a civilization, and this Indus civilization has been severely impacted by this disappearance of the Saraswati river, which was flowing between the Satluj and the Yamuna river systems was there. So the river has supported the civilization, and the disappearance of the river have also caused this fragmentation of this civilization, where everything has been disturbed apart. how much it is serious and relevant to the present day system. Some of the picture shows that it is still relevant. These are some of the figures, and on the y-axis, it is showing the monthly discharge values, and x-axis is the month. So during during a school time period, we have seen that most of the water is going as a waste, and which is going to ocean, and so this water should be stopped. And then number of attempts have been made, and we can see that the curve or amount of water on this river which was going toward the ocean has been decreased. But then there was some of the repercussions also there. These are some of the major rivers: Ganga, Satluj, Andhra, just at the downstream of the barrage. So at least, so it may not be true for all the river, but at least some part of the rivers gets dry out at the downstream of the part. So the impacts are there at the reach scale things. The question is that whether this impact is significant at the longer term scale, at the basin scale. So we have to think about this part, and to analyze these things, I have thought that what are the parameters I should do, and then how to analyze those things. And as I was thinking about the anthropogenic impact, thinking about the river support to the humans, so idea is there that why not think the river as a living appearance, living being, and then see that how much stress is there. So this idea about river as a living being is not a new idea. Many times it has been discussed, and in fact in 2017 New Zealand government has granted the legal right of one of the river, which is the third largest river in the New Zealand, as the legal status in the part. And now that it is still in the news, and then people are talking about this, and then what kind of the different changes had happened at the part. Just 1 year after, even the High Court of India has also given the legal status to the Ganga river systems, and even though and then in this system they have defined the Ganga within the Uttarakhand regions as minor, and the guardian will be the state government as well as the NGRB. But the state government has gone to the Supreme Court, and Supreme Court halted the decision. But the idea is that this has been discussed, and at least for a few years there was a legal status to the river systems. And also there was one study from Australia, and some of the studies are there. These are the things at the present system, and from mythology we all know that it is there in the perception that rivers are in the goddess. So when I'm going to discuss the river as living being, it is not exactly new, but I'm going to discuss some of the research question on the basis of that if we are going to define the river as living being, and then try to assess the stress on the river in the present system as well in the future, then what will be the major research questions will be there. So once we define the rivers as the living being, first thing comes at the health. Again, the river health is not a new concept. It was first time in 1999 it was suggested, and this concept was not came from the hydrological science or morphology science, but in the freshwater biology it was published. And what they suggested, that river health can be defined on multiple parameters, which could be defined in 4 different parts: hydrology, physical, biological, and chemical. And river will be able to function all it works related to all these 4 parameters. Then we will call the river as a healthy. If the river will not be called as if river will not be able to function at least some of these parameters, then it will not be healthy on the parts there. So okay, so based on these things, there were new dimension has added in the river studies, and nowadays the focus on the river health is So now the focus on the river health is more on the it is the interaction between geomorphology, hydrology, and ecology. Geomorphology is nothing but how the river behavior and appearance and behavior of the river system. It is a physical aspect of the river. Hydrology is the water and its characteristics, dynamics, and ecology is the biodiversity. All these 3 things are related. For example, the change in hydrology affect the velocity and depth, which will affect the ecological habitat, and also it will affect this sediment deposition and then the processes, which will change the morphological feature on the system. Similarly, if the morphological feature will change, it will change the habitat, because morphology defines the habitat of the ecology. And then ecology means this different kind of disturbances many related with the biota affect the morphological processes are there. So all these things are there to define the new themes and new terms, which is called the ecogeomorphology, and it has opened this new dimension of those parts. So if we think about this new dimension, it gives us a further new area which is called as the river science, and this new science is emerging. It is again 2007 work, so it is last 10 or 15 years these new concept has started coming out. And river science was nothing but how to take care of the river health. It means that besides water, we have to also think about the physical process, the hydrological process, and the biological process are there. Again, it was the term was coined by USGS, and it was from the division of ecosystem and the fisheries division. It was not from the hydrological divisions are there. And it shows that how much the wide areas of research has been opened out in the river sciences. And now there are the booklet which are available, and this is there. So based on these things, if we think about what is the river science, it is the study of processes that affect these 4 different processes: hydrology, geology, chemical, and ecological process at different scales. Different scales means if we take some sand from a river system, then there is an interaction of microbiotas within this part, sand, and then water, these hydraulics processes which are operating within this part. If we are thinking about a river reach, suppose the Sabarmati reach between the Gandhinagar and Ahmedabad, then we have to think at the different hydrological process, morphological pattern, channel pattern, and then the fishes, so the different kind of species will be there on this part. So it is an interaction of all these things which comes in the river science. And once this river science comes, then this river is not limited to within the channel, but everything is the part of the river processes or the river science. It includes the forestry, it includes the hill slope processes, the landslide, soil erosion, then the groundwater, connection of the water, groundwater. All these things becomes the part of the river science, and the interaction of all these processes are the part of the river sciences. For example, if we take a hypothesis whether this deforestation on the Himalaya has enhanced the flooding impact in the Ganga plains, then this is a research question related to river science, because we are talking about the one process which has happened in the hinterland area and one process which had happened in the plains areas are there. The connection of these things are still not known, even though some of the hypotheses are still there. So these are the questions are there within the river sciences. And if I combine on all these things, and what we did that we have think about that what are the different themes or the processes which are related to that. And all these things, meteorology, hydrology were already there in the river science, but there is a bigger role of the geology, hill slope process, fluvial geomorphology, geochemistry is there. Also there is a role of the ecology, water quality, climate change, and then the new tool like statistical and geometry. All these things are there part. And if we have to understand the river, we have to work for the river, then the integration is needed. And I put these slides many times that if we are working only a single discipline and try to understand the river behavior or the river response, then many times we will be wrong, because our knowledge will be limited. And aim is that integrate the part, otherwise we may wrongly interpret the elephant, where the river is our big elephant nowadays. There. So with this background, I will come on those parts that what are the things which are going on and what are the different questions which are there in this part. And if there is any question, please stop me at the time, and then I will answer the part. So this GRBEMP started in 2010. It is a 1 decade old where the consortium of IITs, more than 100 researchers working on different disciplines. So as I mentioned in the previous figure, now this river science is open, where this people working on different aspects: agriculture, forestry, geology, soil science, and climate change, and of course hydrology, glaciology. Everything has a potential to contribute. And then some of the research questions were defined. The basic part was that river must function as an ecological entity. This was a major change from the earlier studies. In 80s, the major management plan was the Ganga action plan and Yamuna action plan, which was focused mostly, or not mostly, but only on the water quality issues are there. But here the water quality is only one of the issues, but all these issues are important. And when we talk about the physical, hydrological, and the ecological aspect, then these things become important. The river must flow continuously, that is defined as the Aviral Dhara, and river must not be seen as a carrier of waste load, which means the pollution should not be there, and it should be very well connected with all the components from the hill slope, from the tributaries, and the connection is very important for its liveliness. And with all these things, for a river channel, there should be sufficient space. All these four things actually support the ecological entities of this part. So I'm going to address these three questions, which will define that what are the three most basic things which a river, if we think if we consider river as a living being, and what are the three most requirement which should be met, and then we can define that whether the rivers are under stress or they are not under stress. So when I started thinking about the living beings, and for the human beings, then first three things which comes to the mind is the things about these three aspects. And for river, the routine kapla is nothing but the water, sediment, and nutrient fluxes. And water, it is more like a medium, and then sediment and nutrient is the lifeline for the river. And in general, when we talk about the fluxes, which is a flow rate per unit area, and we try to model and analyze the data set. But these three things are important. This is essential, and it should be there whatever the requirement is needed. And the second aspect is the river space, basically equivalent to the makan in these things. And what is the river space? Is it significant? That's what we will see. And we will see that whether both of these things are able to meet or not. And when we see the fluxes, then there are two aspects. One is the water. Water will define that whether whatever water is there in the river system, is it sufficient for its functioning? That is called as the environmental flow, or in this GRBEMP terminology, it is the Nirmal Dhara. And then whatever water is coming, it will be sufficient only when it will be very well connected with all part of the river space, that is the Aviral Dhara. So first I will discuss the river space, and then I will move on to the research question related to the E-flow, and then the connectivity issues are there to address the stress, the present day stress condition of our river systems. So to add this part, excuse me. So to add this part, if we are thinking about river as something as a living being who has to do some work, we have to think about its power, because then power will define whether it will be able to do the work or it will not be able to do the work. And power is it is governed it is being derived from its potential energy, and is defined as the liberation rate of kinetic energy from its potential energy. It means that if the water is moving from point A to point B, then there will be change in potential energy, and that change will be converted into kinetic energy, as well as the heat loss because of the friction, and that energy or the rate of energy will be used for the action of the part. So we have to see that what are the parameters which affect these aspects. So so from these things we know that this power is coming at the rate of potential energy. Mass we have broken down to volume into density. It is there, but the rivers are of the different length, and every river will have its own power. So to work out with a single parameter, the stream power is defined for the unit length area. So it means that whatever power is being generated because of the downstream flow of the movement, it will be divided by length. Then it has been rearranged, and volume and time has been rearranged. This is the volume of water which is passing through the cross section area, and delta H by L has been arranged. So this is nothing but the general slope. And gamma is the unit weight of the water, Q is the discharge. It is the amount of water passing in a unit time through the cross section areas is there. So how much water is flowing and what kind of slope is flowing, that will define the power of the systems. But some of the places this cross section, river cross section may be wide, some of the cross section, river cross section may be narrow. If both the river cross section will have the same amount of the stream power, the distribution of the power at the unit area will be different. In this narrow zone, the power will be concentrated. There will be more erosion, more sediment transportation, whereas in this case, it will be dissipated within the cross-section area. So for further work, actually, the unit stream power is being used for the analysis of erosion and then the deposition process. where the steam power is divided by the channel width and watt per meter square area. So this is the one basic things, and many times we will discuss the steam power aspect. And before moving to river speak, there was one more slide I will discuss, that is about the basics of the geomorphic work. So once river has a power, it can do a different kind of work. And from the book, we know that these three kind of work happen: erosion, transportation, deposit. I define in such a way that if river have a sufficient power, it can erode the sediments, it can transport the sediment. But if it doesn't have the sufficient power, if the amount of sediment supply is more in the system, it will deposit the things. So process will govern by these two aspects. One side we have the slope and discharge, which is nothing but the function of stream power. On another side, we have the sediment size and the sediment load. And it is a balance of these two which defines the physical changes and appearance and behavior of the river system of the part. Now the sediment load is, again, it is not a simple terms. There are the different kinds of terms are there. And in a river system, the coastal sediment used to move at the base, and they move through the rolling, sliding, and through the jumping process that's called as the saltation. But it remains close to the surface, where the finer grained particles and in the effect of the turbulence force, they remain in the suspension form. And they remain in suspension. They don't deposit on the surface, but whenever water overtops its surface, like in this case, if the normal condition of water is there, then the bed load will be deposited on the channel bed. But during the flood time period, the suspended load, those fine grained sediment will be distributed and then deposited on the surface. This surface is called the floodplain. So floodplain is the surface which is then defined as the sediments, which is defined as a surface which is formed by the sediment of the river and deposited by the river itself, and which also gets inundated by river at the regular interval. So it is getting regular interval inundation, and also the sediment, the suspended load deposit had been formed on this part. So, and the another aspect is of course the dissolved load, where the which is being studied to analyze the weathering processes of the part. And in this talk, I will keep the focus on these two aspects, suspended as well as the bed load aspect. This grain size variation also being the variability of the processes and variability of the appearance within the channel and outside the channel. So now comes on the first part. As I mentioned earlier, I'm going to discuss the three issues when I was going to discuss the river as a living being. First, the river space. Second is the environmental flow, the amount of water, and third is the connectivity. So first is the river space. River space is defined by the floodplain. Floodplain, just now I have discussed that this is the surface which is formed by the deposition of the sediment brought by the river itself. And when the river remains connected with the surface, the floodplain is also characterized by the different kind of features. So the features also gives a new inferences about this part, because as I mentioned that the channel part is characterized by the coarse grained sediment, and then this other part of the floodplain will be characterized by the fine grained sediment, clay and silt material in these cases. So there will be variability of the grain sizes, variability of the pore spaces, and that will bring the variability of the groundwater movement in the system. So in general, the floodplains are considered as the fine grained sediments, but because of the presence of the many channel sand bodies, the remnants of the part, number of sand bodies, number of sand patches also remains within the floodplain, and that defines the groundwater dynamics on the system. And that dynamics defines the significance of the part. Significance of the part, you have many times read in the newspaper. Some of these things are, I'm going to highlight on this part, that the floodplains have been there in the discussion on the newspaper. So NGT-DDA, there was also the Art of Living Festival was there in the main heading lines on those pages. Then there was the floodplain of Amravati was also there, and then again the Yamuna floodplains, all these things. And also I will like to highlight this part, that it is so much of the bigger issue that even at that time the Minister of Environment and Forest has mentioned that that some of these major construction have came out on the different places, because that was the space for the river. It was not a space for the human being. It was encroached by this part. So there was a sensitivity, there was the things, but the question is that why the floodplains are so important? Why this compaction of floodplain is so important on the Yamuna river, where the Yamuna is already so much polluted? And yeah, I mentioned so in this talk, as the river pollution has already been studied and discussed the part, I'm not going to discuss the river pollution as part. My talk will be focused more about the morphology, hydrology, and then the ecology interaction of the part. So, so again, back to that part, the question comes that part that in this Yamuna floodplain, why the compaction becomes so important, where so much of the pollution is already there in this part, and how much damage it will happen, and then what kind of damage will happen, may occur on this part. So I will take 2 or 3 examples and then summarize this part. There's what is the role of the space and what are the controls in this part. This is a case study from Delhi University, Professor Shashar Shekhar and his group. He's working on the Palla village, which is at the upstream of the Delhi area, just at the border of Haryana and Delhi. And what they did, they have done the mapping of the floodplain and then analyze the groundwater potential of the floodplain. As I mentioned, that in the floodplain, there used to be a patches of sand, and this is a 3D architecture. This is the Yamuna of the same areas. It is only 8-10 kilometer long stretch, and some of the patches of sands are there in this part. But these patches of sands are sufficient because during lean period, it is providing 41 to 49 million meter cube per day drinking water to the Delhi Jal Board thing, and it's only a small part of the floodplains are there. So floodplain actually a source of water for river during lean period, and during flood time period, river inundate the surface. It fills the water in those sand patches, which forms a very good aquifer. And during lean period, this water moves from the aquifer to the living period, and rivers don't get dry out. So it is essential hydrological component for the lean period also is there. This is another such figure which is showing that different kind of sand bodies have been mapped in those areas are there. So one important thing is that it provides that the subsurface architecture of the floodplain provides a vital lifeline or as a hydrological input during the lean period condition are there. So if these things, if the pore spaces of the floodplain will be compacted, the surface will be bulldozed, it will affect the health of the river. That's why this floodplain connectivity is important. Second important part is there, its connectivity on the surface. This is also called as the flood pulse concept given in 1995. So what it is says that when river inundate the surface, it takes the nutrients from the floodplains and bring it there. That nutrients provide the food and support to the riverine biodiversity to this part. If river will get disconnected from the floodplain, if it will not be able to inundate the surface, then this riverine biodiversity will be affected on those parts. So subsurface and surface, both those parts, it is a part of the lifeline of the river. It has to be protected, and river needs to provide this space. But how to demarcate this space? And that's where is the problem, because the surface of the floodplain is not a uniform surface. This is an example from the Yamuna river in the infrared band, and the water is looking dark because it absorbs the light infrared band. So during the lean period, this is the Brahmaputra river, and during flood time period, we can see some of the dark patches. This is a flood water. So all these things, so which shows that everything is part of the floodplain in the systems are there. It means that if we can map some of the features on the floodplain, we can identify the active floodplain, and which will help us to define the river space of the system. This is one such case study which we have carried out on the Yamuna river, and which shows that number of features have been marked on the Yamuna river systems, and based on these features, this floodplain area has been identified this part. So the geomorphological approach is already there, and a detailed mapping of the geomorphology is good enough to highlight or to mark the active floodplain in the region. There is also another approach which comes from the hydraulic approach. So in hydraulic approach, we look for the inundation periods of the part. So 1 is to 100 year period, 1 is to 10 year period. That will define that how much area will be inundated in this part. That approach is been it is very common in many part of the world, but because of the limited hydrological data, this approach has not yet been applied on this part. So what do we have based on the geomorphic approach? We have the floodplain map. So dark brown color is indicating the floodplain map, and further there is a further detailed geomorphological part is there. But right now let's focus on only on the floodplain. What does it say? That floodplain doesn't occur everywhere. It starts occurring at some of the points, and then it expands, and it expands in kilometer. And this is the downstream, and then further downstream there is expansion, and then further there is a contraction, and then again little bit expansion, contraction, and those things happens at the part. So river space is not a fixed area. When we talking about river from upstream to downstream, it varies. Part these things are there, but it is a very important part. As I mentioned, that it defines the hydrology and ecology of the river system. And river needs the space. It is just like the human beings needs the space, whether the space is the small size or of a bigger size, but the small is needed to keep their health of this part. And this kind of approaches for the mapping of the floodplain is essential for providing the healthy river houses. So this there. Now to think about the stresses, now we all know that okay, floodplains are there, but most of the floodplain have already been encroached and meshed, and many of the floodplains have been where the river has been separated by the embankments in the system. So rivers are many times disconnected on the parts. So all this mapping and then effort shows that in terms of the space, most of the river reaches are stressed. They are not sufficient amount of space left for the river. It has been used by the human development. Things are there. Then one of the research questions come that what controls the floodplain development? Why do we start getting the floodplain at one point and not at the other point? For that, we have to think about the distribution of stream power, which was the main force for the distribution of work, and then see that how it varies from upstream to downstream. So it is a function of discharge and slope. If you think about the discharge downstream, this is with respect to length, it increases with respect to the power equation. And then slope actually decreases in an exponential profile. And if we merge both of these two, then we will get a very different kind of pattern. It will be a complex pattern. So what we did that we have derived the equation for the exponential profile and then this profile in one of the river basin. And what they find out that single exponential curve is not sufficient. If we fit the two curves, this red curve it has been longitudinal profile of the river, which has been derived from the this distal elevation data set, and then it was also measured some of the reaches in the field. But the fitting of the curve is showing that it is not good enough. But when we add one more exponential curve, it makes a very good fitting of the curves are there. So if we merge this equation of the slope and this discharge profile, we will get this equation of the stream power distribution along the long profile from upstream to downstream, and we get the distribution of this part. The red color is the basin scale distribution of the stream power is there. And then yellow color is indicating it is based on the earlier approaches. Before that, some of the attempts were also being done, which was then only based on the single exponential curve. That was not good enough to explain the processes in the field. Now this bimodal distribution of bimodal distribution of stream power suggests that the stream power used to be very high at the upstream area. That's where the erosion is dominated. Then it declines, and it again regains because of the discharge input, because water input is there, and then it take a peak and then again declines in the system. This is a stream power, not the specific stream power. If we further divide it by the channel width, we will get the stream power, and channel width also increases downstream. So let us see this question of floodplain with the distribution of the stream power things. This is a simple sketch which is showing that floodplain is starting at this point. There is no floodplain at upstream, and then we have a wide floodplains on those things. And what we find out that on the streams, the floodplain actually occurs in between this inflection point, where the peak and troughs are occur. So peak generates the sediment load in the river system, and the sediment load, when the river is transporting the sediment load, the troughs make sure that not much of this sediment will be transported and deposition process start. And that's how we are getting the initiation of the floodplain. Further, it is a distribution of this light colored lines. If you can focus, these are the reach scale variations are there, which then further define the small scale distribution pattern or the variability in the floodplain processes part is there. So yes, this basin scale distribution explain the floodplain. They are controlled by the stream power, or the power we will say, sediment, which is the lifeline for the river system, and then the space. All these things that defines the formation of the floodplain. These kind of policies are very common in many parts of the world. And in India, in fact, in the coastal zone, these kind of mappings are there, where the different parts of the coastal zone has been defined for the different types of activities. Such type of things are under consideration of the part, but right now there is no such scheme that how to use the floodplain for this part. And by that time, of course, we can see that in terms of space, the rivers are a bit of stressed, or the rivers in India are a bit of stress. So what I highlighted, the significance of floodplain in terms of the base flow contribution, because during lean flow, lean season, it provides that water. Then the nutrient transfer is there from the surface. Floodplain also define the habitat, because it gives the different kind of roughness of the surface. There are different kind of sediments which are present on the surface. So that gives the habitat for different kinds of variable biotas on this part. The last important thing, which is very important in this part, is space for the sedimentation. This especially that is important where the sediment supply is higher. And this is the space when the amount of sediment supply is high in the system, then we need a space where river can spread or deposit its sediments. If we reduce that space, then river will not able to deposit the sediment. It will move to the other process. And some of the case studies are like this. This is the example of the Kosi River in the North Bihar. It has been embanked all along this length. This yellow dotted line are indicating the embankments. And it is characterized by the very high sediment load in the system. Because of this, the hypothesis is that because of the embankment, this rate of siltation is very high, and river is depositing the sediment at a very high rate. And this bed level is rising in these cases. Because of the rising, river may shift at one particular time. And in 2008, actually river had shifted its position. So what happened in 2008? So when the amount of discharge was not even like a flood discharge, it was 40% less than this, whatever the maximum capacity of the channel the time, but it has shifted its channel because it has broken down one of the embankment and started flowing on this part. It created a huge amount of damage, a major flooding impact, but it was not an overbank flooding. It was a shifting of river because its space has already been occupied by the sediment of these things. And this is just showing that how much the devastation was there. 22 kilometer wide channel was flowing. So what we did, we have gone into the field and measured this bed level at the different cross section. Just two of the cross section I'm showing here. And this is the cross section which is showing. On the left hand side, this is the elevation of the river bed surface, the channel bars. And this is the floodplain. In general, river used to be flow at the lower level and the floodplain used to be higher levels are there. But at this part, actually floodplain is around 2 meter, and in this case, more than 2 meter lower than the river bed level is there. So whenever river will break the embankment, it will start flowing in this direction rather than in this direction are there. Same thing at the another reaches are there, 29.88 meter and 28 meter. There is a close to 2 meter difference between the floodplain and then the river bed surface. Floodplain is at the lower elevation as there. And this is again this extrapolated map where the green color is showing higher elevation, blue color is showing lower elevation, and river is flowing at higher elevation. This is the seepage channel outside the embankment, which is there at those parts. So whenever river will break the embankment, the river will started flowing on those things are there. So which is a common tendency, and there are a number of indices. All those things have been done. This condition is called as a super elevation condition. It is a typical morphological stage which is being defined on the change in elevation, change in slope, and all those parameters suggest that super elevation condition has already been reached. This channel reach is occurring at the upstream of the Kosi barrage areas, where the Kosi is bringing huge amount of sediment. This river has been jacketed. There is a barrage at the downstream, so most of the sediments are depositing on those parts there. So again, it's a story where this river space has been occupied and river has to shift its position, and when it shifted the position, we call it the hazards aspects of there. And these things become important, as I mentioned, that because when the sediment supply will be more, so that defines the sensitivity of the different things in the part. So, so these yellow dots are indicating that these are the yellow dots are indicating that sorry, on the y-axis we have the sediment yield, and then yellow dots are the points on the North Bihar rivers, which is showing the sediment supply from the Nepal Himalayas significantly higher compared to the other parts of the Ganga plains in the systems are there. So this from the long-term study, we already know that the river is of dynamic nature. It is sensitive because of the high sediment supply. But further, with the incorporation or with the addition of the human disturbances, then this rate of change has been enhanced, and river has moved toward the stress condition. More such kind of things are also there in the other rivers in the Bihar. These are our work from another tributary of the Kosi is called the Bagmati River, which originates from the Mandu regions. And then we can see that all the different kinds of channels are there which got amended. And then we are seeing the different kind of bridges are there. So at one of the image, it is showing that these are the changes which are happening. And it is showing because of the siltation process. Siltation is one of the aspect is, of course, because of this jacketing or the presence of embankment, and the other aspect is related with that. There are some of the new tectonic movements are also taking place. So all these things actually affect these flood hazard scenarios. And in India, most of the flood hazards are related with the embankments, and where the good amount of length of embankments have been created. But this flood hazard measured had then had lead to the more population affected, more damage, because these processes are very, very different. We have not yet understood this part things. So first part was the river space, and then some of the river space where I given the example of the part that there are the stress condition. Second thing is that how much water is required by the river system. That is defined as the E-flow, as I mentioned earlier. And already the state government of Himachal Pradesh and then the Uttarakhand government had defined some of the environmental flow, that all the hydropower thing, they have to release at least 10% in Himachal Pradesh and 15% in the Uttarakhand Pradesh. They have to release this much water in the river system. That this much water, 15% of this water, of the monthly annual water, should be able to flow in this part. Now, there was one methodology was applied for the integration of all the ecology, geomorphology, sociological aspect to put the data and then analyze the hydrology and hydraulics. And what we got in the team is that this is red color is showing that this much percentage of the water is needed by the river. So red color during the monsoon period, it is only 10 to 15% or 20% water is there. Most of the water is allowed to free, because that 20% water is good enough. You have to take care of the functionality of the river. But during the lean period, you can see the 50% water is there, and in the Rishikesh, it is going up to the 65% of the water of the mean monthly flows are there. So it means the 60% of water actually needed by the river. We have defined that how much water is required by our hydropower or urban center or for industries, but we have not yet defined that how much water is required for the river system. And as I mentioned that right now only 10% water or 15% water has been released. So rivers at the downstream of the hydropower station are heavily stressed, especially during the lean flow period. So if I put this example, during the lean flow period, rivers are heavily stressed. There's not enough water for the functioning. And during monsoon period, there is a good amount of water as well as the sediment. But because we have also constricted the space, that good amount of water, they don't have the space and they are moving to the another parts of there. Another example of the stress condition of the part. So yeah, I will be a bit fast and maybe. So how much time I have?
I think you have around, say, 10 minutes.
Okay, 10 minutes. So I will finish this part. The next thing is it is a connectivity, is that how the different aspect is then related with this part. The connectivity, if we look for some of the recent review paper on the geomorphology, it is now defined as the emergent properties of those things. It is again only decadal year old things. The first paper was there in 2005 and 6, and it is similar to this part, that if we would like to understand the human body, we would like to understand the whole connected net of these parts. There are some of the things which have been mentioned, and then it is important because if we have to understand the biophysical fluxes, dynamics of sediment and nutrients, and then operation of the geomorphic processes, as well as the future, we have to have an understanding of those things are there. There are some of the indices which are there, and these are some of the example. where these hill slopes are connected with the channel. So in this case, hill slope is not connected because of this presence of terrace. In this case, it is connected, and same kind of things are there. So to analyze this part, one approach is that some of the empirical approaches have been defined about the connectivity index, and this connectivity index has been used to define that which part of the basins are very well connected and which part of basins are not well connected. These are then related with the function of the slope, area, what kind of roughness of the elements are there, and we have used those indices to map some of the features are there, which is showing that there is a variable amount of connectivity in the systems. So the same amount of COSI where the downstream part is affected, this connectivity has helped us to find out where from the maximum amount of sediment is generating in this part. And so for that part, with the connectivity, we also integrated the stream power map, which was then derived using the hydrological model, because during the monsoon period, we get the most of the sediment transportation. These are the validation and observation data. I will come on the final things. And this is showing that once we merge this stream power map and the connectivity map, it explains that where from the most of the sediments are coming. So most of the sediments are coming from the Arun River part. It is this particular part where this stream power is high. You can see this dark red colors, and then the hill slopes are very well connected. All those parts are there. And then another things are there. We have the highest stream power on the western rivers, and then also the hill slope connected parts are there. That also explain the variations in the sediment supply at the downstream. There's not much data available within the Kosi River, but at the outlet, whatever data is available, it explains the variations are there. So using this approach, we were able to explain the inside part is there. This is the outlet part, and the another argument which again showing that Arun is contributing a maximum amount of things. Second thing is that to look the direct about the sediment load, this is the Yamuna, and in the Delhi area, it has been affected by a number of barrages, and then in general discharge amount of water increases downstream. There is taking a dip, and dip has significant impact of sediment transport process. And you can see that in this part, there is not much sedimentation is going on. So downstream of Delhi, in fact, river is not only dead in terms of the water pollution, it is also dead in terms of the geomorphic activity part. There is no work going on. And because of this part, this blue color is showing this upstream peak, the peak at upstream of the Delhi, and which has no impact on the downstream variations are there. And also the similar things, there are some peaks at the upstream of Delhi areas. All these peaks of the sediment concentration on the y-axis has been lost out. So even though Yamuna is considered as a Himalayan river system, but it is heavily disconnected. Downstream of Delhi part is not mostly governed by the Himalayan process, but it is governed by the sediments from the cratonic rivers, and it's been governed by these kind of processes are there. Another kind of, these third kind of methods which have been used as the geochemical mapping. This tool has been mainly developed at the PRL itself, where this isotopic signature of the rock of the different parts of the Himalaya has been used to find out the source of the sediments. And on the basis of the source, we know that some part of the Himalaya is contributing more amount of sediments compared to the other parts of the regions. And within this, from south to north, we know that higher Himalaya is contributing more amount of sediment. And one of the small things are there, that in the smaller stream, what we found out that lower Shivalik, which is a low elevation streams, that is also contributing in the stream, because most of the channel sediments, the sediment are showing the isotopic ratios which are very close to the Shivalik regions are there. So this is another mapping which gives an idea that which part of the Himalaya is more connected to the downstream part, which part is less connected. Again, I will move to this part. It is only showing that the same isotopic signature to see that the part which are glaciated terrains are providing a very good amount of sediment supply, but the sediment is not reaching downstream. So this glaciated part is not connected with the downstream part is there. And there is inferences, it means that glacial erosion will have a limited impact in terms of the sediment mobility in the river systems of the part. So I will go this part, and then the fourth aspect is that to derive the stream power distribution at the broader scale as well. And as this geochemistry based proxy has also shown that the Ganga is the major source of the sediment, and our stream power plots also showing it is the major things are there. These are some of the plots, and which is showing that the values of stream power for the Ganga and Kosi, it is in the in terms of the millions watt per meter square, watt per meter, whereas in the Ganga it is only few thousand watt per meter. So there is a significant amount of difference, and that is why this amount of sediment which are coming in this part, and once it is coming, they are making the channel shallower because of the deposition, and that is why this sediment, this stream power is less here, and steam power is more in the UP plains, less steam power in the plains, high steam powers in the hilly zones. It means extensive deposition, and that's why there is a more and more flooding in this part. So all these processes also help us. The connectivity gives us some of the inferences about the processes part. So next 5 minutes I will discuss. So what I discussed these three parts, river space, connectivity, and the e-flow, and all those things shows that rivers are in the stress conditions. And what is our future? And next 5 minutes I will going to finish this part. We have already the climate models, people have predicted, but the climate models have been integrated with the hydrological models, and for different time events, these scenarios have been generated, hydrological scenarios have been generated. They are the uncertainties, there are different models which also produce the different kind of variabilities, but we have this understanding of those, at least one of the basic data sets are there. But the problems occur that even if we know that hydrological changes, or like here, it will make the changes in terms of sediment and water. So water changes are known, but the sediment changes is one of the major impact. It will change the processes, change the shape, and that will affect the river health. So even if we know the climate and the hydrological model, our future of river health is still an unknown, because the sediment dynamics is a major problem. One issue I highlighted is the connectivity. Second is the threshold aspect is there. So what happens that when this sediments comes in the river system and the stream power variation is there, then this shape of the channel will change. That is called as the morphological change. Morphological change brings the ecological change because the habitats will be different, but the changes occurs in the thresholds in a jump-like motion. It is like that. It is not a continuous motion. So if you have two systems which is lying in one or two, and same kind of change will happen, this system will remain in the same kind of things like a meandering river, but this river system will change to a meandering to braided river system. It means if the system is close to the threshold, it will be sensitive to the hydrological changes. If the system is away from the threshold, then it will be resilient for the changes. And so these kind of questions we have to study, and there are the different kind of channel patterns are there. I will not go into the details, and these are important because it defines the nutrient zones as well as this the ecology. It means that whenever we will change the appearance of the river system, this whole ecology of this things will get changed. We have the present day understanding of the ecology. I have already shown the detailed mapping of the Yamuna river. Similar mappings are already there for the Ganga river, and some more other river systems are there. But the question is about the future. What will happen if we put that hydrological scenarios over these hydrological things? And this conceptual things comes on the defining the threshold, where the stream power is one of the parameter, and second thing is then defined as the how much power is required to time. So stream power is available power, and this is power required to transport the sediment. That is called as the critical power. If the ratio of these two will be close to 1, it means the system will be very close to this part. It will be very sensitive. It will change the position. If the threshold will be away from the 1, it will be resilient of this part. And there is a need to understand this part is there. Right now, the understanding of threshold of those geomorphic system is very limited. 1 or 2 only case studies are there, but even though it is not in the numerical cases are there. So this is the scenarios of the model. Climate, hydrological models are there, but the lack of geomorphological models is a major hindrance to know about the future trajectories of the river system in terms of the river health aspects is there. So that's a summary point. And what I discussed about, the river space, and the data shown that river space has been contracted and is showing the stress condition. E-flow, wet period, there is a sufficient amount of water, but lean period, this is a very less amount of water is there. And it is 1/5 or 1/6 amount of water which is flowing in these conditions part. Connectivity, the Himalayan part where the dams are not a major thing, they are mostly connected, but alluvial parts are heavily fragmented, they are disconnected, and this disconnection and then the contraction space is also defining the river dynamics, and then the flooding aspects are there. This is the present day scenario, and if we put it on the future scenarios, there are further many other complex scenarios occur, And that mainly, first thing is because of the complex and non-linear response of rivers to the hydrological system. That's one of the very important thing is the threshold. There are some more other parameters are there. We know about some of the data of the climate and hydrological model, but the absence of geomorphic models is there. And this is going to be and this should be the future studies that are there. So in this study, what I highlighted, it's some aspect of the multidisciplinary aspect. I have discussed some of the features that river studies needs, the different research question, different kind of tools to answer this part. And still I have not yet touched all the different aspects, things. And this kind of talks, I also take this opportunity to invite researchers, because river science is open to all. It's like the number of research questions which can be defined and answered for the different kind of tools, they are unlimited in the things. And these are very important river questions are there. So this is the very much multidisciplinary studies are there. Only some of the components have started coming out in the picture, and they have provided a new understanding of the river systems are there. One more thing which is going to be studied is the part, the river health and social health is still at the hypothesis stage, and there is a need to integrate the social science with the river science aspect, which is still yet to be take off in India. So the aim is that also to highlight that what are the major changes are there. And once we have the science aspect, we have the solution. Another challenge comes here in terms of the implementation part. And I have mentioned about the river and the connectivity issue, that river is a basin scale things, but when it comes to the implementation part, the rivers in India are the state issues are there. So if the rivers are moving from one state to another state, then this basin scale approach will not work on this part. Besides this, the different aspect of those river science are governed by the different kind of ministries. So there is a need to be an integrated approach of this part. Water resources, Ministry of Agriculture, Forest, Ministry of Environment, Forest, and then Ministry of Rural and Urban Development, Ministry of Earth Science, all the different components, so different processes and components of river are governed by different things. And I hope that soon this will be worked out, and then integrated approach will be there. But what is needed more is that work out an integrated approach at the science aspect, and that's where the boundaries between the departments or the institute has to be broken down to answer some of the fundamental questions on the river science part. So I thanks to all. And with this, I also would like to show one of the figure which I shown. It is from one of the biomedical journal. It is about the human and about the distress and behavior. But what I feel is that the river needs to be analyzed in this framework, and that stress condition, there's external forces, mainly the human disturbances, the changes in fluxes, needs to be defined, that what kind of behavior, which is the morphological changes are there, and that will give us the much more deeper understanding of the processes. So thanks again for this part.
Thank you, Vikrant. It was a really nice talk. What I will do is, like, I'm requesting people to ask questions in the comment section. There are one or two, and I will probably read it to you, and you can answer them. One is kind of just an observation on comment by Arvind Singh, which is saying that basically, that is it correct to use the word Anthropocene so far, because it has not been approved by officially, like either through ICS or IUGS. I know that we use that term quite liberally, but is it like correct in a way?
Yeah, Anthropocene has not yet been approved by the IUGS, but that's fine. The thing is that Anthropocene indicates that the human impact is significant. It is not that one part or one reach has been affected, or one part of the Earth space has been there. The Earth, the atmosphere, water, delta, we have given the example, ocean. So everywhere we are getting the influences of the Anthropocene. So yes, the major debate is there, that what is the origin point, where to put the boundary between the Holocene and the Anthropocene, whether it is the initiation of the agriculture period, 6,000, 7,000 years back, when the huge amount of sediment has been released on the river system and on the landscape, or it is only 100 years back for this part. So there is still some of the debates are there, but the impact. So the idea is to show the impact of the humans, and we have to start thinking about those aspects.
Okay. Thank you, Vikrant. Neeraj has a question which I think everybody has. Like, do you think it is a good idea to link the rivers for the health of rivers themselves?
So thanks, Neeraj, to highlight this, to raise this issue. I mean, as you've seen that there is not much data. Like now, earlier these river trees were only focused only on the hydrological studies and then flood hazard part. What we need about the river health is geomorphological data, ecological data, and there is not much data on the river part. So the first answer is that there's not sufficient data to answer this part. Second thing is that now it is, this is my personal comment, that this is a relatively old concept, because now in lean period there's no water in any of the river system. All rivers are facing the problem of this water. I have shown you the example of the E flow, and then as per the environmental flow, 50 to 60% of the water which is available in the system should be released in the river. But downstream of the hydropower, only 10% is allowed to be released, because the another discussion is that if the hydropower will release more than 20% of the water, then it will not be viable economically in the part. So there are the different issues are there. So the main thing is that there is not much water for the lean period. So even if we connect the rivers, then what we will transfer, and during monsoon period, everywhere we have the sufficient water.
Yes. Okay, Jyoti has two questions. He was also online. So his first question is, are the Himalayan rivers older than the Himalayas? And the second one is, like the Amazon, does any of the Indian rivers have underground flow?
Okay, so first part is that all the Himalayan rivers are older than the Himalaya. Then some of the papers on the anticline theories suggest that it is definitely older than the Shivaliks. So when the river was cutting, it has cut the HFT part. Now when this higher Himalaya was forming, that is not known, that because right now the origin point is there on the higher on the higher Himalaya, it has been contributing. There was one paper by Montgomery which suggests that it has cut this anticline which is formed on the higher Himalaya regions, and some of the major rivers like the Ganges and Indus, they have cut the anticlines and they are the older. But we don't know about the other river systems, whether they are older than the Himalayan part. Amazon river systems, again, so when I was preparing these things and also discussing with some of my colleagues, there's again not much work available on the groundwater surface water connectivity. Of course, and whenever there is a sandy rivers are there is a underground flow will remain on the system. But what is the connection? How thick is the aquifer below the river system? That things are still limitations are there. Only things which are available from the Yamuna river, they are the aquifer, and wherever the floodplains are there, aquifers are there, and those aquifers are connected with the Yamuna river, and which is showing that underground water flow is there.
Okay, thank you, Vikrant. Other question is from Hariom Bucks. I think it's what is the implication of legal status of rivers? And the second question he has is, what are the reasons for disappearance of a river?
Yeah, so legal appearance is the main topic. This came out that who will be the guardian and who will take the decision. And so when the High Court has also defined the river as a legal entity, they define river as a minor, because they cannot speak for yourself. And then their guardian will take the decision, and NGRBA director and then the chief secretary of the Uttarakhand government or make the guardians of the part. But it is, but the river passes through different countries, and it also passes through different states. Then who will be the guardian? Who will take the decisions, and how the decision at one place will affect the decision of the decision on the other places? These are all the complexities are there, and that was one of the reason also given by the Supreme Court, and that decision was halted. So that was the one thing. Second thing is that once this river will be defined as the legal entity, then we have to define that whatever the space and water will be required, and we have to provide that space, the minimum value. And once we provided that space on water, then of course the repercussion will come in terms of the space. There are the number of real estates are there on the floodplains. There are the amount of water which is then based on the industry. We suppose the industry, agriculture activities, there will be repercussions. Second question is about the disappearance of the river system. Disappearance is mainly because of the disconnection with the groundwater. It is the disconnection which is coming on the surface. So first thing is that some of the tributaries also get disconnected with the water. So the tributary contribution which was coming to the rivers, which is not there. And second is the heavily withdrawn of the groundwater from the floodplains. Now, when the floodplain doesn't have the groundwater, because that groundwater has been taken out on the surface, then it will not provide that seepage, the base flow to the river during the lean period. And that is the major reasons for the disappearance.
Okay, thank you, Vikrant. I don't see any other question. So just one question I have is like now we are damming a lot of rivers, right? Like say for example Ganges. So which kind of major geomorphic changes you see after the damming, which was not during the natural flow of the water, or which has? I mean, do you see anything on the ground?
Yeah, so I will give the answer on the basis of the general understanding, because there is still not a data set to highlight that what kind of changes had happened. So what happens that once the sediments get locked at upstream of the dam, the downstream reaches get sediment starved, and the first thing happens is the erosion of the bank or bed at just downstream of the dam, because water then reoccupy or try to regain the balance between the sediment and water at the downstream reaches. Now, this sediment is then has to be transported downstream, but the problem is that that amount of water is same. In fact, the amount of water is also reduced. So water will not be able to transport this extra amount of sediment which has been generated. So you will get the depositional elements at the downstream part. More deposition means shallower rivers that may lead to the flooding hazard, and here the erosion will lead the more of the bank erosion and then shifting of the channel. These are the common things are there. Once the sediment supply, these things will change, then the pattern may also change. Meandering, braided, anabranching, and now based on the recent classification, there are the hundreds of different types of river channel patterns are there. They may change. Once the channel pattern will change, then the ecological habitat will change, and then may affect the ecology aspect. So there is a cyclic episodes are there, but right now there is no such detailed study of any of the detailed study on the geomorphic impact of any of the dams.
Okay, thank you, Vikrant. I think with this, I will hand over to Professor Pallam Raju, our Dean, to conclude the colloquium, I think.
Thank you, Sanjeev, and thank you, Professor Vikrant Jain, for this very nice and nice presentation. You showed very interesting analogies and cartoons and schematics to drive the point, and you did it very effectively. Thank you very much for this wonderful and informative talk, and it's definitely highly contemporary. And I really on behalf of PRL, I would like to thank you for taking the time off and talking to us in this way. It's been definitely beneficial and educative to all of us. Thank you very much, Professor Jain. Yes,
many thanks, and it was an excellent opportunity to discuss these aspects of the river, all the things. So yes. Thanks again to PRL and to all the participants.
I would also take this opportunity to announce the next colloquium, which is also very relevant. I think it will be once we come down to the earth and rivers. Now we are slightly going up. We're going, that talk another. We have another exciting speaker, Professor Ravi Nandindaya, Director of IITM, talking to us on variability of monsoons at different scales. And I would really, request you all to join us next week, Wednesday, 6th January. I'm sure, the colleagues and friends joining from IIT Gandhinagar would also be interested in this topic. So please, I take this opportunity to invite you all, and I'll invite all the colleagues of PRL, past and present, and all others who are viewing this colloquium to please join us in the new year. I wish all of you a happy new year. We are coming to the end of this 2020 and look forward for a brighter 2021. Thank you very much.
Thank you, Vikrant.
Yeah, thanks a lot.